In the last video, I promised that my next video, that would be this one that you're watching right now, would have just a whole bunch of example problems on using trig ratios and special right triangles. Well, promise made, promise kept. Here we go. We're going to start with a video on special right triangles. All right, here I've got 10 problems using special right triangles, and I've even been so helpful as to provide for you notes so you don't have to actually have them in front of you. You should still absolutely have them in front of you. In fact, hey, Mr. Cunningham, remind yourself to put in really big letters on the screen right now. Make sure you have your notes in front of you. Awesome. Moving on. But before we do that, I have a super special bonus problem. This problem was provided by a student, and it is an example of just absolute mathematical perfection. This is an example of a problem from Pythagorean Theorem Challenge on Khan Academy. And I bet it drove most of you bonkers because on its surface, it looks pretty much impossible to solve. It says here that Carol bikes 1 kilometer east, so that's right there, and then 4 kilometers north, and then 5 kilometers east again. And your job is to find the distance. How far away is the end point from the start point? And anytime you're talking distance, you're talking Pythagorean theorem, but they set it up in a tricky way. They make you think that there are 2 right triangles, but in reality, there's only one. So check this out. What if Carol, instead of going east and then north, what if instead she went north for 4 kilometers and then east for 1 kilometer? Has she moved any more or less distance than she would have the first way? Well, no. And now what we've got is we've got a right triangle that has one leg of 4. This other leg is 1 plus 5 is 6. There's our right angle. And we can just separate that out. 4, 6, x. This is an example of a problem that is both frustratingly simple and really deceptive. There is absolutely no shame in struggling with this problem because most of us are not yet trained to see that kind of pattern. That's what math class is for. So no worries if you didn't see that right away, and I'm sure some of you are shaking your fists at your screen right now because the answer ends up being so simple, and I'm sorry, I don't know what to tell you. So now we use the Pythagorean theorem. 4 squared plus 6 squared equals x squared. 4 squared is 16, 6 squared is 36, so we get x squared equals 52. We get x equals the square root of 52. Let's zoom in on 52 really quick. Remember that I do want to keep my square root. I don't want to plug this into a calculator because it's going to give me a decimal which I will have to round, making it inaccurate. But I do want to see if there's anything I can do to simplify this. So 52 is an even number, so at the very least it's divisible by 2. 52 divided by 2. Well, 50 divided by 2 is 25, and 2 divided by 2 is 1, so that would be 26. Well, 26, well, that's 2 times 13. Prime, prime, prime. So what we have is the square root of 2 times 2 times 13. I'm double checking on my calculator just to make sure I haven't made a mistake. 2 times 2 times 13 is indeed 52. And because we have 2 squared here, 2 times 2 is 2 squared, we can take the square root of that. That is 2. That's these two together. You take the square root. And then the only thing that's left under the square root is 13. So the final answer is 2 times the square root of 13 kilometers. That said, looking at the actual problem, it does say to the nearest tenth of a kilometer. So it looks like we're going to have to use that calculator anyway. I'll make sure to leave a time tag in the comments for these problems. All right, here we have 4 different 45, 45, 90 triangles. All right, and in the center is our notes. These are the ratios. We know that the 2 legs are congruent, and we know that the leg to the hypotenuse is a multiplier of times the square root of 2. Right? That is from a couple videos ago. I will drop a tag right now. Let's look at number 1. We've got 2 times the square root of 2 as the leg. Well, looking at our notes, we can figure out what one of these sides is right away, immediately. By the way, if you want to get the full benefit out of this video, please go ahead and pause the video, look at these 4, and leave it paused as long as it takes for you to make a really good, really honest try, a really honest attempt at all 4 of these problems. Even if you don't really know what you're doing, give it your best, give it as much as you can, because every step that you manage to take on your own is a step that is going to stick with you much more strongly than one that I just tell you. Now, we know that the 2 legs of any 45, 45, 90 triangle are congruent, so we know that B is 2 times the square root of 2. In fact, we can look at any of these problems, and I've actually got 6 of them here, where if we have one of the legs, we immediately have the other one of the legs. So this one over here looks kind of ugly, but all I have to do is copy-paste. And this one over here, y is 3 times the square root of 2. Again, if you have one leg of a 45, 45, 90 triangle, you automatically have the other one without having to do anything. The multiplier, the ratio, is 1. Okay. So now, how about that hypotenuse? Well, according to our diagram, to get from a leg to the hypotenuse, you multiply by the square root of 2. Which means, if I was going the other way, if I had the hypotenuse and I was looking for the leg, well, it's just the same thing, except since we're going the other way, we're going to divide by the square root of 2. If you don't remember why this relationship exists, again, check out the video that I linked earlier. So for number 1, we should get 2 times the square root of 2 times the square root of 2. The way these work is that whole numbers multiply with other whole numbers. Square roots multiply with other square roots. That's a little oversimplified, but that's basically the size of it. So this 2 doesn't have anything to multiply with because it's the only whole number being multiplied. Square root of 2, square root of 2, that's the square root of 4. Well, we know what the square root of 4 is. That's 2 times 2. The final answer is 4. Take a moment. I went through that pretty quick. Let's have a look at number 2. Well, in number 2, we're given the hypotenuse is 4. So to find the legs, we take that 4 and we divide it by the square root of 2. And because they're both legs of an isosceles right triangle, they're both the same. Is that it? Is that really it? Yes, that's really it. I promise. Now, there is one small itsy-bitsy little complication. There is something that Khan Academy has against, and the mathematical community in general has against having square roots in the bottom, in the denominator. For some reason that I have not been able to figure out, despite asking many professors over the years why, there's just, for some reason, we have a problem with it. So we are going to learn in a little bit later how to clean this up so that you can recognize it on a multiple choice problem. But for now, 4 divided by root 2, just leave it there. And again, don't get your calculator out, don't give me decimals, not unless it is a word problem. Okay, so number 3 looks like a nightmare, but again, let's take it one step at a time, okay? We have the leg is 3 times the square root of 2 divided by 2, and we're multiplying that by the square root of 2. Now remember, just like in the last video, we're not multiplying the top and the bottom by the square root of 2, because this is the square root of 2 over 1. Again, whole numbers divide with whole numbers. We still get 3 over 2. Square root of 2 times the square root of 2, well, we did that before. So what we get is 3 times 2 divided by 2. Right? The square root of 2 times the square root of 2 equals 2. Well, what's 2 divided by 2? It's 1. The answer is 3. Again, this just takes a lot of practice. Let's get a little bit more practice, shall we? Number 4. And yes, I will back up and give a nice steady shot of all of these so that you can pause the video and write them down if you need to. X would be 3 times the square root of 2, that's the leg, times the square root of 2. Well, we've already done this. That's 3 times 2. That's 6. X equals 6. The square root of 2 times the square root of 2 is 2. 2 times 3 is 6. Here's where I pause for a moment to give you time to take a snapshot or write this stuff down. And now that moment is up. I'm going to do these two, and I'm going to do them very, very quickly because I want to show you just how fast these can be done. In fact, go ahead and pause the video and see if you can get these done really quick. Ready, set, go. Okay. Now, watch carefully. Check and see if my answers match yours. Now, this bit right here was a little bit tricky, especially since I flubbed making it. Right? To get from the hypotenuse, let me use a different color. To get from the hypotenuse to the leg, you divide by the square root of 2. So we get 2 times the square root of 6, that's the hypotenuse, divided by the square root of 2. Again, the two square roots divide to make the square root of 3, and the 2 just stays the 2. The next 4 examples are 30, 60, 90 triangles. So again, I have put in the center of the screen notes on 30, 60, 90 triangles. But Mr. Cunningham, that does not look like the diagram that you made last time. Yes, it does, but it doesn't, you're right. In the last video, I set the hypotenuse as r, the small leg as r over 2, and the longer leg as r over 2 times the square root of 3. Do you see how this is still the same proportion? This time I chose to make the shorter leg x, but notice how the hypotenuse is still double the short leg. The long leg is still the short leg times the square root of 3. The proportions are all the same. How you label it exactly is not as important as preserving those ratios, those multipliers. So quick recap. If you have the short leg and you want the long leg, you multiply by the square root of 3. If you have the short leg and you want the hypotenuse, you multiply by 2. And both of those processes can be reversed by dividing. So let's try one of these. Over here on number 7, we see that we have the hypotenuse. Well, we know that the short side is half the hypotenuse, so y is 8. And we know that the long side is the short side times the square root of 3, so this is 8 times the square root of 3. We're done. This is why we sort of encourage students to memorize or at least take notes on these special triangles, because once you get the proportions down, and once you get the hang of moving back and forth between these sides, it gets really quick. Let's take a look at number 8. We have the short leg again. The hypotenuse is twice the short leg. The long leg is the short leg times the square root of 3. We're done. We have the short leg. It's 8. The hypotenuse is twice that, which is 16. And the long leg is the short leg times the square root of 3. We're done again. Number 10 looks tricky. We have the hypotenuse. So to get to the short leg, we need to divide by 2. So this will be 8 times the square root of 5 divided by 2. Well, again, remember, ordinary numbers divide with ordinary numbers. 8 divided by 2 is 4. And the square root of 5 does not have another square root to divide with. So we get 4 times the square root of 5 for the short leg. To get from the short leg to the long leg, we need to multiply by the square root of 3. So we get 4 times the square root of 5 times the square root of 3. Again, square roots multiply with square roots. 4 does not have anything to multiply with, so we get 4 times the square root of 15, which is our answer. So there are 10 examples of special right triangles being solved. Right now in the video, you should see some links to many more example videos. Make sure to click on those if you still don't understand. Shoot me an email, show up for my office hours. Have a great one. I'll see you next time.